side angle, hypotenuse leg, angle, angle, angle. What were the ones that worked? Do we remember which ones worked that we can use for congruence? Which ones? First four, SSS, SAS, SAA, and then what about this? Hypotenuse leg. What can't I use? This guy, and angle, angle, angle. Maybe they could be, but I can't prove congruence if I notice that. So let's see how we try to use these things here. Side, side, side congruent. So here's our theorem, actually a postulate. If 3 sides of one triangle are congruent to 3 sides of the second triangle, then the 2 angles are congruent. Okay? It's a postulate, so we're not proving it. But I think you guys can see, how could it not be true? Right? Can I make any other triangle out of these? I can't. So it must be that the angles are the same. We use SSS to say side, side, side. It means this whole thing is kind of condensed into SSS. 3 sides of triangle are congruent to 3 sides of another. They are both congruent. So here's an example. So, proofs. You're given AB congruent to CD. Always mark your diagram. Always. AD congruent to CD. Prove that the triangles are congruent. Now, before we even look at the proof, you can see how it's going to happen. Here's 1 side congruent, 2 sides congruent. The third side, are they congruent? Where's the third side of both triangles? Yeah. It's the same side. They share a side. So by what property is BD going to be congruent to BD? What? Reflexive. Remember reflexive? It's the property of congruence now, right? Because we're working with congruence. So I have shown that 3 sides of a triangle are congruent, therefore the triangle is congruent. And that's all I need to say. The side, side, side congruence postulate shows me that. Okay? We can also look at some other examples here. Now, based on just looking at a picture, these are not on your paper, but just looking over here, are these triangles congruent? What do you say then? Yeah. Why? Well, what are they telling me? All the sides are congruent. So by what postulate are these congruent? Right? We have to actually state why. You can't just say because they tell me. I didn't tell you they were congruent triangles. I'm only showing you 3 sides congruent. So you have to say, no, the triangles are congruent by the side, side, side congruent postulate. Right, Thomas? Right. Okay, how about these guys? Are these triangles congruent? We're looking at ABC and CDA. What do we see here? I see 7 is congruent to 7. The 9 is going to be congruent to itself. What about the other side? No? So are these triangles congruent? No, not congruent. How about this? Triangles congruent? Right, I see a side, a second side, and a third side. Yes, they are by side, side, side. Trivial, right? Oh, that's easy. I hope it's easy. Now what about an coordinate plane? How can I show that the triangles are going to be congruent? ABC, right? ABC to CDE. How can I prove them congruent? Remember our friend the distance formula? Who remembers our friend the distance formula? Thank you. Thank you 4 or 5 people who remember that. Because it's still here, it doesn't go away. Because if I use the distance formula, can I find the length of this one? And let's see, AB is going to correspond to CD. So I want this one and this one to be congruent, right? What else do I want to have congruent? BC to DE. Which is some colors here. Right? AB is going to hopefully be congruent to CD. And BC is congruent to DE, this one. And AC is congruent to CD. Now, how do I know these are the congruent pieces I should have? How can I tell? How can I tell? Are you okay over there? Really rude. I'm sorry, Yes, these have to match up, right? So AB and CD are congruent, AC and CE, BC and DE. So I'm using that little helper to see which they are. So we're going to run them through the distance formula. So AB, these are my points. What's the distance between -4 and -3? AB is -4 to -3. It is. It's 1, right? Yeah, it's 1 squared, right? So 1 plus the distance between 2 and -3 is 5, right? It's 25 if I square it. So the AB is the square root of 26. Let's look at CD, right? CD is his match. So the difference between -1 and 4, well, that's 5, right? Square it. Plus the distance between 1 and 0 is 1 square that. So are they congruent? Okay, so I've got that one. BC, I'm going to look at, where's BC? These two. The distance between -3 and -1 is 2, and I'm going to square that. Plus the distance between -3 and 0 is 3. That's 9, so you square it. So that's square root 13. DE, let's see. Here to here, 1 to 4, that distance is 3. Square that, you get 9. The distance between 3 and 1, that's 2. Square that, that's 4. Also square root 13. So these are congruent. And now I just need to know about AC. Distance between -4 and -1, that's 3, right? Square that, that's 9. Plus the distance between 2 and 0 is 2. Square that. Well, that's also square root 13. CE, C's. Distance between -1 and 1 is 2, right? Square that, that's 4. And the distance between 3 and 0 is 3. Square that, that's 9. Square root 13. So these are congruent as well. In fact, I could have made them with 2 little lines because those are congruent. So are these congruent triangles? Are they? Yes? By the side, congruent postulate. So that distance formula to help us see if lengths are congruent too. I did it real quick. Hopefully we're getting a little bit faster with the distance formula. And a few U-tries here. Yeah, go ahead and spend a couple minutes on those. For just a couple of minutes because we're moving on a little bit. Questions on any of these? Some of these are semi-obvious because they start getting a little bit harder for D and E. Questions on D and E? How about F with the using the distance formula? Do we get the same distance, same length? Same length of the side? No question. Okay. Let's look at the next one. We want to look at side angle side, congruence postulate. Also a postulate. Don't have to prove it. If two sides and the included angle of one triangle are congruent to two sides and the included angle of the second. Underline that word included on your paper there. Because what does that mean? To be the included angle. What does that mean? What does it mean to be included? Yeah, well, you're in the middle. When you're an included angle, you're in the middle. You're between those two sides. So you have to kind of, if it says side, angle, side, right? Then you have to read it as side, angle, side. Your angle can't be up here. Right? So you read it in order. Side, angle, side. Very important. The angle is in between those two congruent sides. Yes? They are the rays of the angle. Yeah. You could say that. Otherwise, that's not the same thing. So be very careful that if you're using side, angle, side, it's side, angle, side. Same order that you would kind of list it off if you were reading it. So here's an example of a proof. With these, I always like to just see, can you figure it out first? BC congruent to DA, and I know they marked it up for me already, but get in that habit of marking up a diagram. BC parallel to AD. How are we going to prove that these are congruent triangles using side, angle, side? Right, you know we're using that because it's our example here. Well, how am I going to do that? Well, I see another side, right? Why is AC going to be congruent to AC? Right? Reflexive property. So I need another angle. Now, if these are my two sides, where's that angle going to be? Here and here, because that's the included angle. Side, angle, side. Side, angle, side. Can I get those two angles congruent? Can I? Why are those two angles congruent? Why? Yeah, we had there's a mess here. This one is not the congruous. This is why I prefer saying, if two lines are parallel, then their alternate interior angles are congruent. Then I don't have to worry about which one's the converse. Right, some of you may have lost a half a point or so on the test for that. Why are these two angles congruent? So if two lines are parallel, then the alternate interior angles are congruent. Kind of like why I prefer writing them out. Because then I don't know who's the converse, who's the regular, I don't know. But I do know this. And then these are congruent by the reflexive property. So by side angle side, the two triangles are congruent. Let's look at another one now. Side angle. I do have a little picture here. If we didn't get this to work on our little lab that we just did, here's the triangle, right? Now let's see if I can show the other triangle. See how I can swing that leg over? So I still have an angle, a side, and a side that are congruent. Do I have congruent triangles? No. So sometimes they are, sometimes they aren't. So can I use that one? No, I can't use it. So side angle does not work. Now before I move on from side angle, well, we just got to go there. How are we going to remember that this is the bad one? This one doesn't work. Oh, it's laughing. He's reading it backwards, I think. Oh, who's laughing? Right? And I always like to, I better shut off the recorder here. Donkeys don't work. Right? Donkeys don't work. And that's how I remember that this is not the good one. Some of you are looking at me like, what do you mean? Just read it backwards, and maybe you'll know what I'm saying here. Right? Side angle. Right? Donkeys don't work. Right? But there is a special case where it does work, and that's what we saw again in our little triangle lab. If your other angle, right? Here's a side, and an angle. If that angle is a right angle, it does work. We call that hypotenuse-leg. So remember, just as a reminder what these things are, right? A right triangle, I know it's a right triangle because of the right angle. The side opposite a right angle is called a hypotenuse. And then the other sides are called legs. So if you have a right triangle and the hypotenuse sides are congruent, and either of the legs, it could be like this, or maybe you have these two legs congruent. Either one of those, then you do have a congruent triangle. We use HL to say hypotenuse leg. Right? So side angle generally does not work, or we can't use it to prove congruence. But we can use hypotenuse leg. And I'm looking at an example here. Oh, look at this. WY, again, this one was not shown. They didn't mark it for me, so I better do it. WY congruent to XZ, WZ perpendicular to ZY, WX perpendicular to ZY as well. Prove triangle, let's see which ones they are here. WZY, this one, is congruent to XYZ, this one. Now sometimes when they overlap like this, maybe pull them out so you can see them a little bit better. Here's WZY, and let's see what do I have here, XYZ. I know this one is congruent to that one. Do I have anything else? Oh, let's see. Let's see if we can prove this. WY congruent to X. These are all given. Angle WZY and XYZ are right angles. Why is that? The definition of what perpendicular lines are, right? Therefore, the triangles are right triangles. That's the definition of right triangles. And then it says ZY YZ. Why is that? Because if you look back in your original picture, they're the same line, reflexive property. So since I have a hypotenuse and one set of legs congruent, the triangles are congruent by hypotenuse-leg. Just kind of following. We just covered a lot of ground today. About 3-4 people. Who has a question? No, but we don't have questions. Okay. Some new tries here. Decide whether the triangles are congruent. Explain your reasoning. So let's work on those a bit. Okay, which one?
Will we be doing things where we put we have the shapes inside of shapes and
Sure, why not? Sure. Okay, so there are questions on this. Yes, ma'am. Let's see, which one do I want? I want JKL, this one. And I want MLK. All right, so let's see here. What do I know? Well, I've got a common side, right? And let's see, what it's giving me JK is congruent to ML. So I've got two sides, and I've got an included angle. Side, angle, side. So just because it's a right angle doesn't mean it's going to be a hypotenuse. So you always, I got to think, because I don't know necessarily, I don't have the hypotenuse as being congruent. I don't know that. So I can't use hypotenuse leg, but side angle side works for this one.